Hello guys, good morning, good evening, good afternoon. Welcome to this webinar on DevOps crash course. My name is Amit and I will give you a walkthrough of what is DevOps and other important DevOps concepts and tools and technology. So guys, let's talk about our agenda for today's session. So guys, you're going to learn first, why do we need DevOps? Why the whole world is talking about DevOps as the mode of software development come deployment. What is so unique about DevOps? Then we will talk about what actually is DevOps. There's two different concepts. First, why we need DevOps, and second is what is DevOps. Third is, guys, we're going to talk about different DevOps tools and technology. Okay, what are different DevOps tools and technology and different DevOps stages. And finally, we'll see some hands-on on the DevOps tools and technology stack. Now, without wasting any further time, guys, let's talk about why do we need DevOps. What is so unique about DevOps that the whole industry is moving towards a DevOps mode of software development come deployment. Now, in order to understand why do we need DevOps, we need to understand the previous models of software development come deployment and what challenges or drawbacks these models used to offer. Now, I'm pretty sure, guys, everyone in this class would have either worked or would have learned about waterfall model of software development. Anyone who is not familiar with waterfall model, I'm pretty sure each one of you at some point in your careers would have learned about waterfall model. This model almost ruled the industry for close to 4 decades. It was the main model of software development come deployment, the main SDLC model. Now, what used to happen in waterfall model, guys? Waterfall model was the primitive mode of how things was governed or did. So in the waterfall model, the first point of contact we used to call as business analyst, a person who will interact with the customer, gather requirements. Now, once the requirement was gathered by this person called as BA, it used to pass on to the designing team or the architect team. The different organizations used to have different terminologies. You can call them as architects or you can call them as designers. So based on the requirement, they design what solution they want to deliver to the customer. Once the architecture has been complete, it used to go to the implementation team or the coding team. So based on the proposed architecture, which is developed by your architects or your designers, you will start coding a solution for the requirement given by them. Once the coding was completed, it used to go to a testing phase. There used to be happen multiple types of testing like unit testing, functional testing, regression testing, performance testing. And if everything goes fine in the testing phase with all the bugs fixed and all, it finally used to get deployed in your infrastructure lifecycle. Obviously, first the lower lifecycle environment like QA, Dev, UAT, and then the prod one. And then of course, it used to be in the maintenance or continuous development phase. How typically your waterfall model works. How good the model looks, guys, but this model used to have a lot of flaws and lot of challenges. The first biggest drawback of waterfall model was customer requirement used to happen only at two stages. First, when requirement is being given. Second, when product is being delivered. Now imagine I am the BA for a company ABC and I interact with the customer and gather some requirements. For some reason, I'm not gathering the requirement correctly as per the business need. I took some wrong notes, understood the requirement wrongly, and the entire process worked as per my feedback or as per my analysis. Then the product you are delivering will not add any value because you're not delivering what customer is expecting. There was no concept of customer feedback or customer involvement in any stage of software development come deployment. Customer was only engaged when product is being developed and product is being delivered. He was not engaged at any of the phases of development lifecycle. So that was the first drawback. Second drawback, guys, was the typical life cycle of software development come deployment in waterfall model was anywhere from 6 months to 1 year. Now imagine you are my customer, you gave me a requirement in the month of December, and I'm delivering a solution next year, September or October. There are very high chances the requirement the business had in the month of December is no longer relevant by September or October. See guys, when we work in IT, our main aim is to help the business. If business is not seeing any value coming out of IT, why will they invest in IT? The first question. IT as a business is for very few companies. For 95% of the companies, the aim of IT is to help the business. We understand the business problems and we try to solve them. Business cannot wait for a year or 10 months to get their problem solved. They want quick and efficient solutions which can address the modern day changing market needs. Imagine companies like Amazon does a code change every 11.6 seconds once. You are a same company in the e-com business. Can you wait for 6 months or a year to cater to your customer requirement? You cannot. You will be wiped off from the market. That was another drawback of waterfall model. The biggest drawback of waterfall model was there was so much silos among different teams in an organization. Development team has no idea what their infra is all about. Infra team or ops team has no idea what developments are working on. Say for example, Aarti is wrote some code of okay, the code is working fine on Aarti's laptop. Now Aarti is very happy the project she was working on, it got worked. She's able to run the solution in a laptop. Now Aarti went to the ops team and asked the ops team to deploy that particular code in the infrastructure. Now ops team is telling Aarti, hey Aarti, we cannot deploy your code. You wrote the code keeping into account that we are using Ubuntu OS, a Java version, let's say 11, and some Nginx version. In our infrastructure, we are using Java version 2.0. Let's say, for example, we don't use Ubuntu, we use Red Hat OS, and we are not an Nginx shop, we are an Apache shop. Now, what is going to happen here? Aarti is going to push the ops team to rework the infrastructure configuration and make it compatible with her code. Ops team is going to push back Aarti and tell, hey Aarti, rewrite your code and make it compatible with the current infra. Now this pushback and pullback will lead to eventually two things. You cannot deliver the product on time and business will not see value coming out of IT. See guys, you have often seen your manager using the one word, this project overshooted the budget. It's a very common IT acronym, which often your management, your leadership uses. What is the most common reason when projects overshoot the budget? Because of frictions among the team. When you work on a requirement, it's a combination of multiple teams. A single user or single team cannot deliver the final finished solution. If all the teams in an organization will not act in sync, it will not solve the purpose. That is some of the challenges which we had with the waterfall model. Now, keeping into account all these challenges which I just talked about in the waterfall model came the agile methodology. Now, agile guys was very good. It almost solved all the problems which were there in the waterfall methodology. For example, the first thing we discussed that customer interaction used to happen only at two phases, when requirement is being given and when product is being delivered. Now in agile methodology, we are able to overcome this particular error. Now in the agile world, we used to divide our project into different sprints. So sprint is a time duration in which we commit to a customer that will deliver XYZ functionality of the project. Now a sprint duration can be anywhere from 2 to 8 weeks. The industry standard is 2 weeks. Now as part of the sprint, let's say Abhishek gave a requirement that Abhishek wants to develop a web application. So instead of focusing on one big project as web application, I will divide the project into multiple subtasks, which we call as stories. So first story for the Abhishek requirement can be developing a web server. Second can be establishing connectivity between website, the web server and the database. Third can be creating a front-end UI. So that way we can have multiple connectivities. Now, once we have these type of multiple connectivities, what we used to then do is we used to create different stories and place the stories into different sprints based on the priority. Now, once the sprint gets completed, let's say 2 weeks, we used to engage customer at the end of 2 weeks, and we used to get feedback from the customer. If customer is happy with what we are doing on, then we used to just focus on the same path we are working on. Let's say customer is not happy we are working on, we are not delivering what he is expecting. We'll do a quick course correction and we'll start working as per the need. That way we have a continuous feedback or continuous customer engagement mechanism. That was the first good thing which was possible about this particular agile method. Second drawback I talked about in the agile method was the time frame. Because in the waterfall model, the time frame was 6 months to 1 year. A customer need to wait a year to see a product or a development. In the method of agile, we used to deliver the product after every sprint. So we used to have faster turnaround to the business requirement. That was the second improvement which this agile methodology has. Agile was, guys, very good for developers. It talked all about how to make development life easy. It talked about how to engage developers in different phases of development come deployment. But Agile had a small problem. Agile never talked about how to incorporate operation side of a picture. It only talked about how to make development as part of the integral lifecycle, how to make all development team integrate among each other, how to remove friction among the development team. But it never talked about the operation team. So whenever we work in an organization, we have got development side and we have got operation side. We have got operations picture teams like monitoring team, your OS team, your database team, your middleware team, these all are OS team. Now, all these OS teams need to interact with the development team. This was not happening in the Agile methodology. Agile was really good, guys. It was very, very good for development. Even you guys would have seen in your organizations, when you talk about Agile methodology in your, it only talks about development. When it talks about development plus ops, you talk about Kanban board. We never talk about Scrum or Agile board. You guys would have noticed this is the main reason behind it, that Agile was only for developers. It never talked about how to incorporate the operations team. See, Dev and Ops both are integral for any organization. If 60% of the work is development in an organization, 40% is going to maintain my operations team. Keeping the lights on is a big, big challenge. It's not a small thing. Developing is one part of the puzzle, but second is how to ensure that what you have deployed always remains stable. How to make sure infra is up to date, whether it's a cloud infrastructure or you're on-premise. How to make sure networking is working fine, your monitoring is happening properly, you're doing proper updates, proper rollouts. So all those things are managed by your operations team. But that is something was not part of the agile methodology. Now, keeping into mind this agile methodology came the DevOps mode of software development come deployment. As the name says, DevOps is a combination of two words, development and operations. In the DevOps mode, we make sure that all the teams in an organization, whether it's a development team or operations team, they all work in sync with each other with no friction. Okay, that is the first thing on DevOps. DevOps, guys, is based on four fundamental pillars. Okay, the first pillar is cultural transformation, as we talked about, that all the teams in an organization work in sync with each other so that we can deliver the product on time and business can see value coming out of IT. That is the first principle, DevOps. Second is continuous monitoring. Monitoring is very, very vital for any organization. No infrastructure is error proof. No application is bug free. Things go down, things break, infra go down. But a smart organization is before that issue becomes a disaster or an outage. We take some preventive actions and fix it. That is only possible using monitoring. When I talk about continuous monitoring, I'm not talking about just monitoring database or servers. I'm talking about monitoring each and every aspect of your organization. It can be infrastructure server, a database, a router, a switch, a printer, a job, anything that is part of your infrastructure. The third principle about DevOps is automation. In the world of DevOps, we aim to minimize manual intervention and maximize automation. So for example, many of you are developers here, and you would have seen that in jobs like compiling the code, packaging the code, code review and all, you spend a lot of time. In the world of DevOps, we aim to complete all these tasks in less than a minute in a fully automated manner so that we can avoid such repetitive tasks. At the same time, in the world of DevOps, we use something called as infrastructure as a code. Where we provision, configure, and manage our code using some configuration management tools like Ansible, Terraform, Puppet, Chef, which helps us to automatically manage our infrastructure in a seamless, uniform way. And the fourth principle of DevOps is right blend of tools and technology. In order to achieve the first three games of cultural transformation, monitoring, and automation, we need to use the right blend of tools and technology. So these are the four fundamental pillars of DevOps. Now, since we talked about what is DevOps, let's talk about what all tools and technology comes into picture in the DevOps family. So as you can see, guys, DevOps is divided into multiple stages, broadly classified into 8 stages, and different tools and technology fit into different life cycles. It starts with the planning phase and it ends with the monitoring phase, the last phase of your DevOps life cycle. So planning phase is where basically you interact with customer, gather requirements, and create your stories, basically subtasks. To do the planning, you use multiple tools like Jira, Pivotal Tracker. There are many which can be used for planning phase. Now, once you have planned, developers start working, they start writing the code. Now, when you write code, guys, your code written by multiple developers. You need to solve some basic problems. Who made the change, why the change was made, and when the change was made. The three W's, very, very important. Collaboration is one piece, okay, how multiple developers collaborate. The another piece of puzzle when you've got big team with multiple developers is who made the change, okay, why the change was made, when the change was made, right? So today, let's say for example, AK worked on some piece of code and AK moved from organization A to organization B and AK was replaced by Abhi. Now Abhi is supposed to take care of that code and do some bug fix or improvement, whatever. Now, until Abhi knows why AK made that change and what was the requirement, it's very difficult for Abhi to make those corrections. That is why we need some version control system tools like Git, which can answer the piece to these puzzles. Now, let's say we are using some versioning tool where we are storing our code. Using versioning, we are doing collaboration, parallel development, and having all those advantages. Then we need to automate the build process. We used to use some tools which can automate tasks like compiling the code, packaging the code, code review, code build. So for that, we use some build automation tool like Maven, Ant, Gradle. Now, depending on which programming language you have written your code, determines which build automation tool to use. For example, if you write the code in Java programming language, you're going to use Maven as a build automation tool. If you're using Python, you're going to use Ant or Gradle. So depending on those, you have to use the right build automation tool. Now, once you've done this build automation, you use testing. So gone are the days when we used to have manual testing. Now, whether I perform regression testing or functional testing or performance testing, I write some test cases and execute those test cases to achieve our end goal. That is where we use certain automation testing tools like Selenium. Now you can see guys, in the middle, we have box called integration. We call them as CI tools, continuous integration tool. These CI tools basically are called as your heart of your entire DevOps pipeline or DevOps lifecycle. All the DevOps tools and technology interact with each other using these CI tools only. Jenkins is the most famous or most widely used CI tools. Now, among all the tools, guys, you're seeing on this particular stack, almost most of these tools, if not all, they come in their open source licensing, where they have no cost to use these products. Jenkins is one of the most popular or most widely used DevOps tool. It's a CI product. So using Jenkins, we create some pipelines, a series of interdependent jobs where we can execute our job very easily using some automations of pipeline. So I gave you an example in starting, things like compiling, packaging, code review, code analysis, unit testing. They all can be completed for any complex project in less than a minute using Jenkins pipeline. That is the beauty of using these CI tools. These CI tools are plugin based tools. Using plugins, we connect to another tools and get enhanced functionality. So once we use Jenkins, then finally we deploy our application. How we deploy? As containers. Containers, the gateway towards microservice architecture. Docker is the most famous container solution. We use Docker as the container solution. At same time, we use either Kubernetes or Docker Swarm as the container orchestration solution. So both are different things. Containerization and container orchestration. Using orchestration, you achieve things like high availability, load balancing, and auto scaling for your container. Now, same time, when you deploy an application as container, it needs to deploy it on your infrastructure on any server. How do you do that? For that, you use some configuration management tools like Ansible, Chef, Puppet, Salt, and you use Terraform to provision your code. We use something called as infrastructure as a code, basically writing code to manage and provision your infrastructure. And once deployment is done, there comes your maintenance or monitoring part. We use tools like Nagios, Elk, Splunk, Datadog, New Relic, Grafana, Prometheus, and many others to monitor your infrastructure. So this is in brief, guys, what is DevOps and the different phases which are there in your DevOps pipeline or DevOps lifecycle. Okay, so now guys, since we talked about in brief, let's talk about DevOps tools and stages a little bit in depth. So your DevOps always starts with versioning. You use some version control system tool like Git, Bitbucket, Subversion, basically to store your code. So versioning is the initial. Once versioning happens, then comes the continuous integration phase. So what is continuous integration? You automate your tasks like compiling, packaging, code review, code analysis, integration testing. That all happens in your continuous integration. Then comes your continuous delivery. Now you see guys here, there are two terms, okay? Continuous delivery and another thing, another term you can see on the right of yours is continuous deployment. Now difference between delivery and deployment guys is in continuous delivery. When you deploy application to a lower lifecycle UAT environment and you want to promote to prod lifecycle, prod environment, you have got some manual intervention. Okay, it can be a change control process. Okay, it can be a change control process, your manager review, all those things. But in continuous deployment, there is no manual intervention. Your entire deployment from lower to prod lifecycle happens using in a fully automated manner. That is what is continuous delivery and deployment difference. And finally, monitoring. The monitoring is needed at every stage, whether you are doing an automation build, you're deploying a lower life cycle of prod in whatever manner, you need continuous monitoring. So these are in broad guys, different stages in your DevOps lifecycle or DevOps pipeline. So now guys, let's talk about versioning, version control system. Version control system guys, versioning tool are basically classified into two categories, centralized and distributed. So centralized is basically old way of versioning used to done, and distributed is the modern day architecture of your source code management. So see in the diagram, guys, in your centralized approach you used to have two-layer architecture, a working copy and a remote repository. While in distributed, you used to have three-layer architecture, a working copy, a local repo, and your remote repo. Now, in the centralized approach, what used to happen is, let's say you're a developer, you write some piece of code, you're working on workstation one. Now, if you want to upload your code into your remote repository, what you will do is you put a lock on the particular project. Something like SharePoint used to work. So I'm pretty sure many of you would have worked on SharePoint. So how SharePoint works, you put a lock on the project, and once the lock on the project is done, no other developer can make a change or remove that lock, right? So once that is done, until unless the developers release the lock, no other persons can make the change. So that was one of the drawback of centralized. Second, guys, your remote server is again going to be some server, piece of repository of server or some cloud environment. What if that server goes down? Again, you're losing your data. That is not serving your purpose. In order to take into account all these requirements came the distributed version control system. Git, GitHub, GitLab, Bitbucket, they're typical example of distributed version control system. In distributed version control system, we have basically three-layer architecture, a working directory, a local repo, and a remote repo. Now, in this, what used to happen is developer cannot commit the code directly from working directly to remote repo. You used to have one more layer called local repo. So imagine you're working on a project. You store some data in /temp. You make a file called a.sh. That is a project. So a.sh is present inside /temp. That is a working directory. Now you will first push the working directory into your code into a local repo. The local repo is present on the same server as your working directory. So basically now you've got two levels where data is being stored. Once your data is present in the local repo, then only it can be pushed to a remote repo. Now, modern day remote repo companies are like GitHub and Git, like we have got GitHub and GitLab. Now, most important thing about GitHub and GitLab is all your remote repos on these particular things runs basically on a public cloud provider. So GitHub basically is owned by Microsoft. GitLab is owned by GitLab companies and which is backed by Amazon. Okay. So now in GitHub and GitLab, when you store your data gets backed into multiple data centers. That is the beauty of using GitLab. Okay. Now, what used to happen in this particular architecture is there is no concept of putting a lock. Multiple developers can easily collaborate and push the data into a remote repository like GitHub or GitLab. Now, in order to send data from local to remote repo, we used to use code like git push. So using git push, we used to send data from local repo to remote repo. Now, if you want to download data from remote to local, you used to use something called as git pull. We use git pull to download data from remote to local. All the modern day versioning tools are based on distributed version control system architecture. Okay, so now guys, let's talk about Git in particular. Okay, what is Git? So Git is a typical example of distributed version control system. So I hope you guys can all see the Git architecture on my screen where we've got something called as local repo and remote repo. And in local repo, we've got three layers, a working directory, a staging area, and a local repo. Now, we never talked about staging area in our architecture discussion. So staging area is an invisible layer between your working directory and local repo. Now, why do the staging area? This we can talk about once we talk about some advanced concepts about Git. But in order to send data from working directory to local repo, you need to first push data into something called as staging area. Now, why we have staging area? Let's say you want to answer the question why the change was made. Who made the change? So all those things are possible using this concept of staging area. It really helps to solve answer to this question. Now, once your data is moved to the working directory local repo, using tools command like git add and git commit, use something called as git push to move data to your local repo, so remote repo. Using git push, we move data from local to remote. You cannot push from working to remote directly. You can only push data from local to remote. You cannot push from working directly to remote. Now, if you want to do other way around, you want to download data from remote to local, you need to use something called as git pull. Using git pull, you download data from remote to local. At same time, if you want to do parallel development, you want to create branches. Basically, why we need branches? Whenever you work in a project, you get continuous development. You get feedback from the customer, and you started working on those feedback and make new development or new code changes. For that, we use something called as parallel development, a branching concept. Now, what is branching? Let's say you rewrote your code and your main branch is called as master or main. So in modern day Git, you call it main. Traditionally, we used to call it Git master branch. So when you start writing code in master branch, you deploy the code, your entire pipeline run, and some application got created. Now you got some feedback, okay, that hey Amit, you need to make certain changes. Now if Amit directly makes a change in the master branch, there are very high chances manually we can make some mistake which can break the code and break down the application because all is integrated. So what we do is we don't make the code change directly in our master branch. Instead, we make the code change into a feature branch or parallel branch like B1, B2, something. And once all the changes are good in those feature branch, then we merge those changes from the feature branch to the master branch. That is how we achieve parallel development. Using parallel command like git checkout, we create branches, and using git merge, we merge the basically the different contents of the branches. That is how we achieve parallel development in the world of Git. Okay, this was in brief about Git architecture. Now let's talk about CI process. So once your code has been put into your GitHub repository, you automate your automation of continuous integration process where you automate tasks like compiling, code review, unit testing, and finally you package your code as a WAR file or a ZAR file. Okay, it happens using CI tools like Jenkins in conjunction with some build automation tool like Maven or Integrator. So as part of the continuous delivery, we first deploy the code into a lower lifecycle UAT. And once the code is successfully deployed into a lower lifecycle, we have some manual intervention where you see, sorry, in delivery, we have some manual intervention where once your manager approval is done, you deploy the code into your prod environment. But same is not true in continuous deployment. The entire life cycle, entire process happens using in a fully automated manner. That is what you call as continuous deployment. Okay, then we have got something called as configuration management tools. We talked about like Ansible, Chef, Salt, Puppet, Terraform. Using these tools, basically, we automate our infrastructure management come deployment. Okay, so whenever you work in a company, guys, you're looking at stack of thousands of servers. Don't you agree? Multiple dev servers, testing servers, prod servers. Often you would have seen, guys, your dev servers are upgraded, but not your prod or vice versa. Using configuration management tool, we make sure that all the servers in our organization are running the same dependencies, same binaries, same libraries. Okay, that is the beauty of using these configuration management tools. When we work on configuration management tools, we use something called as infrastructure as a code. We write our code to manage your infrastructure. Now, the beauty is you don't need to have any programming knowledge language to write your infrastructure as a code. Okay, that is the good part about this thing. When you work on infrastructure as a code, you use some very simple basic syntax. You need to have, for example, if you work with Ansible, you need to have some YAML knowledge. Puppet uses something called as Puppet DSL. It's basically an embedded version of Ruby on this. But you don't need to have any detailed programming language or programming master to work on any of these things. Using this infrastructure as a code, you can easily manage your infrastructure and make sure you're running the same dependencies, same binaries. You can deploy any infrastructure, make any configuration change, start any service, anything you can think of typically is done in your organization can be easily provisioned and managed using these configuration management tool. This configuration management tool typically follows this master slave topology. Now let's talk about Puppet, guys. So Puppet is one of the famous configuration management tool. It was the first tool in this category to be launched in the industry. It's the early bird. Now Puppet is an example of agent-based configuration management tool. When you talk about Puppet, you basically deploy a Puppet agent on the master server as well on the slave node. Since it's an agent-based architecture, it is called as pool-based configuration management tool. It's always a responsibility of agent on the slave node to get configuration from the master node. So how the communication works, as you can see in the diagram, Puppet slave node sends something called as facts to the Puppet master. So facts are nothing, any details which help the master to identify which server is trying to communicate to it. It can be like IP address, server name, its CPU architecture, anything which helps us to identify the infrastructure. Now, once Puppet master receives that information from slave, it sends something called as catalog. So catalog is nothing, it's a detail of configuration that needs to be applied on Puppet slave node. So let's say you're deploying a service, sorry, or you're starting a package, deploying a package, starting a server. So all those things are passed as part of your catalog. And once catalog is applied to the Puppet slave sends a confirmation to the master the job has been successfully executed or not, something called as Puppet report. If you're going with the enterprise version of Puppet, you get the Puppet licensing. And if you go with the enterprise version of Puppet, you get the GUI functionality. where you can see how your configuration is being deployed and pushed. But same is not true with the free version of Puppet. So something to note about Puppet. Now you've got other tools like Chef, Ansible, Salt. Ansible is by far the most famous configuration management tool in the industry. Now next guys, we have got containerization. The whole world is going towards containers, right? So containers are your gateway towards a microservice architecture. When we talk about containers, we talk about two key components, images and containers. You can't create containers without images. You need to first create image and then containers. Now, the difference here is, guys, think like image is like a static file, but container is like a running instance of your application. So when you want to deploy an application, you first create an image. So in order to create an image, think like you define all your dependencies on your binaries and libraries and build them together. That is what your image. Now, once you run your image or deploy your image, the running instance of your image is called as container. There are two ways to create your image, guys. First, you can download the image from Docker Hub. Second, you can create your own image using something called as Docker file. Docker file is the building block of your Docker architecture. In your Docker file, you define all your instructions, all your steps that you want to execute, and then you build them together. Another thing, as I mentioned, is Docker Hub. So Docker Hub is a place where developers, companies store the images. You can download the images from Docker Hub and push your own images and can use them for your requirement. So these are how two ways you can see you can develop your application. Now the beauty about containers, guys, is containers are very lightweight. Okay, so for example, if I'm creating a container on Linux host, then my container will not have its own kernel. It will share the kernel from the host on which it is running. Can you deploy two applications on a VM where application A use Python version 2.7 and application B, let's say, use Python version 3.3, or application C uses Python version 3.0? Is it possible? No, right? In monolithic architecture, your application gets the dependencies from the VM on which it is installed. That's a big problem. But in case of containers, we can achieve all those goals. I can create a container one on a VM where container one uses CentOS operating system, Python version 2.0, and some other dependencies. I can create container two on the same VM which uses, let's say, Red Hat operating system or Ubuntu, Python 3.3, or some other dependency. That is the beauty of containers. Containers are their own world. They have their own set of binaries and libraries. They are not dependent on host OS for any such details. That is the beauty of containers. Now, there are, guys, many container solutions in the industry. Okay, Docker is not the only container solution. Docker, Rocket, Elixir, OCI, Call, there are many. Docker by far is the most famous container solution available across the globe. Don't think Docker is the only solution. There are many other solutions. The last phase of your DevOps lifecycle is continuous monitoring. Now, monitoring is very vital, guys. There are many companies who believe monitoring is not important. I completely differ with them. Right now we are having holiday season, right, where companies are going into complete lockdown, people are going into vacations. There's no development happening as such on major US or Europe based clients, but one thing all of them expects: keep the lights on, make sure your service is 100% up and running. Now how does that happen? You deploy infrastructure across thousands of servers, VMs, databases, routers, switches, printers. Manually, I don't think it's possible to log into each of these instances and check its status, right? I don't think it's possible. Anyone who believes it can be done, even for a Fortune 500 company, looking at means more than 100K devices, which are part of your infra stack, whether you're deploying your infra on-premise or in a multi-cloud environment. Okay. Now that's where, guys, we use certain monitoring tools, which helps us to get some analytics, does some monitoring for us, keep a stack on your infrastructure. If you see, guys, these days, any Google or any companies like Town Hall, they say data is the king. Any company who can harness and tap the data is king in modern day IT industry, because data contains all the key ingredients of what your customer is looking for. So when I say data has been looking, you're looking at petabytes of data, structured, unstructured, semi-structured data. Now, how to convert the data into meaningful results, right? It's a big task. Capturing data is one thing. Okay, you have some data, but how to get some meaningful analysis out of this data? That is where you use tools like Splunk, Azure Log Analytics, Google BigQuery, Elk, which helps to let us derive some meaningful information out of this process. So this is, guys, what all talks about continuous monitoring. So there are many monitoring tools in the industries. Nagios by far is one of the most famous and one of the widely used. Nagios comes in both free and enterprise flavor. We call Nagios Core, it's free flavor, and Nagios XI, it's enterprise edition. So Nagios is a plugin based tool, guys. A very old tool which is based on something called as plugins. Using plugins, we perform monitoring. Its backend is completely done in Perl programming, very native, we will say, in terms of the code it has, but it's very effective. It works in very simple principle. You deploy a Nagios remote plugin on the host you want to monitor. It can monitor Windows, non-Windows, databases, any device you want to monitor. And basically what happens is, in order to perform monitoring, you run something called as plugins. So you can say plugins are like programs where you define certain conditions. If you define a condition, let's say CPU monitoring, it's very simple. You define a plugin to monitor the CPU utilization and you put 80% threshold. Now Nagios, although it's an old tool, it has got some very smart mechanism. To put an alert, let's say if my CPU breaches 80% threshold, send me notification. Now let's say my CPU breach 80%. It will not send me alert instantly. It can be a false positive alert also. Your CPU flickered for a moment from 80% and came back to 80%, right? It's possible. So in Nagios, you can define certain conditions like number of attempts, recheck, whether it's a flapping alert, like on and off alert. You want to get alert only on weekdays or weekends. You want to set up alerting only on US holidays or non-US holidays or some other specific days. All those things can be done using Nagios. Okay. So Nagios has got three core components: Nagios GUI, Nagios scheduler, and Nagios plugins. So scheduler basically does the job of scheduling, what plugin need to run on what server and all those things that is being taken care by scheduler. Plugins perform the job of monitoring, and basically Go is the front end view where you see what is being happening and what is being. So that is in very brief about Nagios architecture. Nagios can send notifications in multiple mode like an SMS, an email notification. If you're using Nagios Enterprise, you get all modern day notification facilities like sending to West webhooks, okay, to Microsoft Teams or Slack. Okay, at same times you can create some functions as part of some automation workflow to alerts and ITSM integration to ServiceNow. All those things can be done with Nagios Enterprise license. So this was, guys, in brief about continuous monitoring. Let's do some hands-on and let's see some of the basic commands and some of the basic ways on how we can install these tools in our life cycle. So first, let's talk about Git. How to install Git? So Git is not an OS agnostic tool. It can be installed on any operating system, any platform. Now, there are different ways on how Git can be installed. So for example, I have made this VM, which is a Red Hat or CentOS. So I've made a Linux-based machine. So if I want to install Git on Linux-based machine, I'm simply going to use yum as a downloader manager and simply run the command yum install -y git. Now, if you want to install Git on any Ubuntu-based OS machine, use apt-get as your downloader manager. On any Windows machine, you can download the Git exe and run it the easier way, or you can use Chocolatey or Choco. So Choco is another downloader manager which is available in the world of Windows if you want to install any package. If you're using a Mac OS, you can use Homebrew or Brew to basically install Git. So simply in the command yum install Git, and since I have Git installed, nothing done, Git install. So if you want to validate Git installed or not, simply run a command git ---- version. So I can see my Git got installed. Okay, let's first talk about tools installation. Now let's say you want to install Docker, another DevOps framework tool. You can simply use a command yum install -y docker, and that way Docker gets installed on your machine. Now Docker, when it gets installed, it gets installed as a service. Run a command service docker status. So you can see my Docker service is up and running. Make sure when you install Docker, the Docker service is up and running state. When I talked about Docker, I talked about two components, images and containers. Run a command docker images. This will list you what all images are present on your machine. If you want to see containers, run a command docker ps-a. PS stands for process. So it will list you what all containers are present on your machine. Now let's create a container. So I want to create a container, let's say using Nginx image, the most common web service. How will I do this? I use a command called as docker run. Okay, I use a command called as docker run. You define then what mode you want to create your containers. There are basically two modes, interactive terminal and interactive terminal detach. So I will use the mode, let's say interactive terminal detach. Want to give some name to your container. So I want to give some name to my container, let's say as Edureka. Now same time, you want to define which image you want to create a container. I want to create my container using Nginx image. Now, when you talk about container, let's say you deploy application as a container, but you want to expose your application externally to your end user or customer. So I'm going to add a flag called as -p for port forward and press enter. Now, many of you might be wondering from where am I going to get this Nginx image? So if this machine don't have this Nginx image, it will download the Nginx image from Docker Hub, okay, the place where images are stored. So once that image is downloaded, it will use that image and convert it into a container with the name Edureka. Let's validate whether my container got created or not. So docker ps-a. So you can see a container named Edureka got created, which got created using Nginx image. And now I can access the container externally, that means over a web browser using the host VM IP address. How to get the host VM IP address? You can simply use a command curl ifconfig.co. So if you want to get public IP address of any cloud-based VM, whether it's a AWS, Azure, GCP, simply use this command. So I'm going to access this URL and see if I can access the application. So port number 32769, right? 32769. See how simply I deployed the application as a container. Simple and easy, right? So this is some of the easy things you can do, like beauty of how we can do containerization. If you talk about microservice architecture, container is the gateway towards a microservice architecture. When you talk about DevOps, one of the very important aspects is how to containerize application. You would have often heard the term serverless function, containers, they all carry the same meaning. Companies are using how to make your application more scalable, how to make them easily scalable, how to make them auto-scalable, the modern day, where tools like Kubernetes come into picture. Someone asked me a question, OpenShift is another container orchestration tool. Now, Kubernetes is known by guys different flavors in different cloud providers. In Azure, you call something called as EKS, Azure Kubernetes Service. In Google, you call it GKE, Google Kubernetes Engine. In the world of AWS, you call it CKS or CKE. Okay, so there are different names by which Kubernetes is known. The beauty about all these tools is like Docker or all those things is, although the mode how you run these tools differ from OS to OS, but their commands are universal. Whether I talk about Git, I talk about Docker, Jenkins, any tool in this category, their command don't change with the operating system. Now, deploying Docker in Windows is slightly tedious than Linux. If you want to deploy Docker in the world of Windows or Mac OS, you need to download something called as Docker Desktop or Docker Toolbox. It's a 700 MB file which you download locally to a system on which you want to install Docker. That is the beauty about Docker. Okay. Now, once you install Docker in your environment, download that particular Docker toolbox, you basically are creating a sort of virtual VM. Using that virtual VM, basically, you're going to access Docker containers. Although, as I mentioned, the mode is different on how you install Docker. So installing Docker in Linux is very easy. Yum install Docker and just start Docker service. It's difficult or slightly tricky when I say that way in the world of Mac or Windows, but Docker commands remain the same. How you build an image, how you download an image, how you create a container, they all remain the same. There's another very beautiful command of Docker world called as Docker info. This command tells you your entire information about your Docker world on this particular machine. So for example, I've got 2 containers, 9 images. This is the version I'm running. What storage driver I'm using? What is the logging driver? So logging driver basically that different like journal D, syslog, Splunk, AWS, etc. The default is general D. Now, am I running this particular as part of Docker Swarm container orchestration tool? What is the default runtime? So all those options you can find out with this information called as Docker info. You've got another command called as Docker top. Okay. So for example, I have these containers and I want to find what process consuming the maximum compute. Okay. Let's say you see your container is consuming too much this thing. Use a command Docker top and give either the container ID or container name. So for example, if I give this container ID with this Docker top command, it will tell me the top consuming process in this particular world of Docker. That is how beautiful this command is. Okay. So if you want to troubleshoot any container, all those things, use the command Docker top. If you want to find logs of a container, use the command Docker logs and then the container ID. That will find all the logs of your container. If you want to find get live logs, if a new log comes up, you want to see on your screen, just add a flag dash F, and that way you can visualize the logs of your container. So that is another important command called as Docker logs. Another thing, guys, is you should never ever delete a running container. So now let's say, for example, Amit wants to delete the container name Edureka, and the container right now is in running state. We should never try to delete a running container. It's always recommended stop the container and then delete it. How to do that? Docker stop and the container ID. Okay. And if you want to remove the container, Docker rm and the container. That's it. That's how you can delete a container. If you want to delete an image, for example, if you use the command Docker images, it will list all your image. You want to delete any image, let's say Nginx image, use the command Docker RMI. RMI stands for remove images. Latest is the default tag value. So even if you don't specify any tag value, it assumes later the tag value and give your image name, for example, nginx. So if you do this, your image gets deleted. That is how you can delete your image or your container. Now, guys, let's talk about Docker Swarm or Kubernetes. These are a container orchestration tool. So right now, using Docker as a container solution, but although running an application as a container, it's running on this one VM, a piece of hardware. This hardware can crash, it can go for patching, some downtime, some maintenance. If it goes into maintain stop state, obviously my container where my application is running will go into stop state. My application stop state, my end users cannot access it. Then there's no point of containerization. To solve this problem, we use something called as container orchestration, where we deploy our application as a cluster. So you've got a collection of nodes which typically follow your master worker topology, and using these nodes, you achieve high availability, load balancing, scaling, roll-ups and rollbacks, where basically even if one node of your cluster goes down or two node goes down, the end user don't see any impact, any downtime. If you're getting more load on your application, let's say it's an e-com application, and right now you've got some sales season, you want to distribute the load among different nodes, then it can scale up and scale down. That happens using container orchestration tool like Docker, OpenShift, and Kubernetes. Kubernetes by far is most famous and most widely used. Docker Swarm is also famous, but Kubernetes is more extensive, it's more vast, and more widely used in the industry. So this was all about, guys, different DevOps tools and technology. So I want to thank each one of you for joining this particular webinar. Hope you would have found the session insightful and helpful and got some understanding about DevOps tools and technology stack. Thanks again and have a great rest of your day, guys. Bye bye. Take care.